As an extension to the previous video, I will just talk about the frequency division thing a little more. So I have three flip-flops here, three T flip-flops with each of all of the T inputs 1 being 1, and the first one Q0 has clock the clock signal connected to it. So let's draw the clock signal first. Let's say this is the clock. So if the clock is like that, it goes rising edge, all the flip-flops are rising edge, so they act on the rising edge. So this is the clock here, and if I connect this clock, this output to here, and then this one to here, what will happen is, this is clock signal, this one, the first one, will obviously act with the clock. So we have something like that, and then this one, this is Q0. Q0 is becoming clock for this flip-flop. So these are the edges whenever it's going from 0 to 1. So this one should toggle, since there's a 1 here, just like the previous one. Since there's a 1 here, it will change when the clock comes. So clock comes here and it changes like that. Similarly, this one, this is Q1. Q1 is connected to this flip-flops clock, flip-flops clock. So this one, the output will toggle only when the clock comes, of course, because T is 1, all of them are 1 anyway. So again, this clock is here, and as we saw, we ended up getting, sorry, not here, it won't change here, it will go there like that. Yeah, let's just finish there. So as I saw, we ended up getting a down counter, asynchronous down counter, since the clock was different. But also what we are getting here is, if this is the time period of this clock, here the time period doubles, so the frequency is half of this one. Similarly, this one, the time period is this much, here the time period is double of that. So this is 2 cycles, this is 1 cycle. So again the frequency is up. So if this one's frequency is f, this one's frequency will be f over 2, since the time period is, if this was 2, this is 2t. Similarly, this one will be 4t, twice of that, and frequency will be f over 4. So frequency division by 2. Similarly, this one, 2 cycles up to there, and this is just 1 cycle. So this is 8t, and frequency is f over 8. So again, frequency division by 2. So we are getting a frequency division by 2 by adding more flip-flops. If we add 2 more, we will get f over 16, and then finally f over 32. So this is how it can be used as a frequency division, digital frequency division, for digital frequency division. So yes.